Chemistry with Pastor Dan. We're going to do a radioactive decay lab, and I'm going to do it in a way that's going to make it easier for you to do it at home. So let's open up the lab first. Okay, so here's the lab. We have the purpose of determining the process ready to decay in a simplified fashion. Common materials simulate the reaction. So count out the number of isotopes in a reaction chamber, place them into the data table. So however many you have, one of the labs I use a reactive isotope pennies, okay? And so I would use 10 of those. Another one I would use m&ms, and so I'd use more here. I put like 40 of them inside of there. And what you do is by saying radioactive, if it's radioactive in the chance of the coins, it's heads up, it's still radioactive. M&ms, if it's the M&M side up, it's still radioactive. So what you're going to do is you're going to put the radioactive material in here, run a half-life, dump them out. However many are still heads up, we're going to put that down for the first half-life. And you're going to keep going until you get to 0. Then you're going to do the next one, and the next one, and the next one, and the next one. And so average them out. This first one's going to be easy because 10 plus 10 plus 10 plus 10 plus 10 divided by 50, still 10, or 40 plus 40 plus 40. So that first average is going to be 40, and then we'll do the average of that second column, average of the third column. So you're going across each trial here, and then we're going to average going down. Now, once you do that, it's really good if you do this with another set of groups. So get other students with you and get their data, put your data down and their data down, and get the average of those information. Once you do that, what you're going to do is you're going to generate a graph. Now, remember, when we do the graph, we're always going to put the independent variable, the number of half-lives on the bottom, the dependent variable, the thing that we don't control, the amount radioactive. So in the case of the pennies, at 0, it would be 10. If you're doing the M&Ms, I would do like 40. And then you for the first half-life, whatever number is there, remember to make sure, so that number come over here, make sure you put a geometric shape around it, and then do a line of best fit. It's going to be a curved line. When you finish up, please make sure always remember to title the graph. It's always dependent versus independent. So in this case, it'd be amount of radioactive versus the number of half-lives. Now, once you have that graph, and it's going to be a radioactive decay process, so a curved line coming down, you're going to use that information to calculate. So graph the data, that's the first thing you're going to do. Then identify the time necessary for reactive to be half. So if you started with 10, half would be 5, and you should come over here where it hits the line and identify the number of half-lives. Would it be a quarter? 10 divided by 4 would be 2.5. So you come over here to 2.5, where it hits the line, go from there. And then quarter, 10 divided by 4 is, and then, eighth on that process. Once you get that information, we're going to see the number of half-lives, and they should follow that process. So half of it should be around 5, a quarter of it should be around 2.5, and an eighth of it should be worth 1.25. So we should be going down as we go. Make sure you do the conclusion there. And it's just a fun lab to go through and identify the process of radioactive decay. Hopefully that wasn't too bad. Take care. God bless. Bye.